Good. Today's lecture is on the scientific revolution. And the scientific revolution for me is made up of something called MO. MO is math, observation, and experimentation. Math, observation, and experimentation. It's kind of like the, what's it called? The scientific, you guys use it? Method. Yes, the scientific method, the scientific process, yeah. People start to use math and observation and experimentation in order to figure out how the world works and come up with laws that apply to the way that the world works. When we go way back in time to really pre-Renaissance, Renaissance Europe, there was a very small number of educated people. During the Dark Ages, really, the only people who had knowledge were churchmen. And churchmen weren't particularly interested in the way the world worked. They weren't particularly curious about that. Because they were more curious about, well, or they really wanted to know, I guess, how to get into heaven and how to avoid sin and live like they should. Well, as we get to the Renaissance then, you might remember that people started to get crazy for the ideas of the Greeks and the Romans. To the extent that churchmen did know something about the world, they too knew something about the world or the universe based on what the Greeks and Romans had said. And so we get to the Renaissance, let's say, and there are really a few Greco-Roman experts on how the world works or how the universe works. And one of them is Aristotle. Now, all of these people are not Christian, which is a little bit difficult for the church, so they sort of Christianize them in a way, make them palatable for Christians and take their pagan ideas and make them Christian. One of them is Aristotle, as I said, and Aristotle deals with natural philosophy, which is the word that people used for science before about 1830. Natural philosophy, the wisdom of nature. Another thing that Aristotle talked about, besides just how the world worked, how matter was made up of, and things like that, is also astronomy. He had some explanations for why things in the heavens looked like they did. Hundreds of years later, there was another Greek person living in the Roman Empire whose name was Ptolemy. And Ptolemy took some of Aristotle's work and slightly changed it a little bit. He was dealing with astronomy. And then Ptolemy was also interested in geography. You might remember there was this Geographica that he wrote, and it was rediscovered in 1406, and it gives the impetus for some of the explorers to try to go to Asia by heading west instead of heading east. And then finally there was a Greek guy by the name of Galen, who dealt with physiology, who dealt with the body, who dealt with sickness and wellness. And so these three guys basically are pre-Christians, and yet they set up what people knew about the world, what they knew about people's bodies, what they knew about the heavens for hundreds and hundreds of years. Now these guys used, for the most part, they used thought and deduction to determine the behavior of objects and to determine how things work. They didn't do experimentation. And so they'd sit around, for example, Aristotle sat around and thought about weights falling, and thought about a heavy weight and a light weight that would be dropped at the same time. And he, just by thinking about that, he said that one of them would hit the ground first. Which one hits the ground first, according to Aristotle, do you think? The heavy one. And you guys have been taught. Has anyone ever actually experimented with this? Have you ever dropped a lightweight and a heavyweight? Yeah. Oh, that's awesome. Good. You actually did that. Well, you know which one hits the ground first then, if you actually do it, right? Which is? They hit at the same time, right? Yeah. So if you experiment, you learn that. Aristotle didn't experiment, so it's a bit of a problem. What they're doing as they're observing is seeing, for example, the heavens, and they're coming up with ideas about the heavens, and so they came up with this idea of a geocentric system, a geocentrum. I'm going to go ahead and call it the universe. I'm not sure that that's exactly true. The universe is much bigger than our solar system, oops, I gave it away, what we believe is at the center of our solar system. But for what they know, the center of everything is the Earth. And the Earth, for them, was surrounded by rotating concentric spheres. These spheres are see-through. You can't actually see the sphere. It is a crystalline sphere. And there are things that are sort of embedded in these crystalline spheres, these orbs of light. This works really well if you're thinking about just observing how stars are moving or how the planets move as you're standing on the Earth. They're moving. Sorry, you guys at home can't really see me, but I don't know if you've ever watched this, but the night sky, it moves, or it seems to move as you look at it. The stars all shift over time if you're watching. That seems to work for the naked eye. This also works for navigators. People who are on ships are trying to figure out where they are on the globe, where they have to turn to the west or east to reach a certain place. This seems to work for them as well. They're using certain stars to navigate their ships. Now, once the Christians came along, they added Christianity to this idea, and they started to think of the earth being filled inside with hell. Deep down inside, at the center of the earth is hell, and there's a bunch of levels to hell. And then if you get beyond the earth and you get into these concentric spheres, then you have at the very most outer crystalline sphere beyond that, you have heaven. Are you guys familiar with Dante's Inferno story? Yeah, it's a wonderful story. You should read that. Dante puts people in hell that he doesn't like, which is really cool. And there are different levels of hell. The outer levels are for light sinners, and the inner levels are for the very serious sinners. There are two people who are at the very center of hell, the two worst people who have ever lived. Do you remember who they are, or do you know who they are? One of them is Hitler. No, wait. One of them is Judas, who betrayed Jesus, and the other one is Muhammad, who also betrayed Jesus in a weird way, if that makes sense to you. Anyway, so that's what they're all about. People believe this. Christians believe this for a long period of time. Like I said, Aristotle, he doesn't experiment. He doesn't try, dropping the weights to see that they hit the ground at the same time. He just thinks about it. Or he does observe, but I'm not really even sure how one would particularly experiment this. He observes matter, and he comes up with the idea that matter is made up of 4 elements. Earthly matter is made up of 4 elements: fire, water, earth, and fire, water, earth, and air. And here's a way that you could think about somebody observing that. Think about burning a piece of wood that's kind of green. It's just been recently chopped down, and you're burning this piece of wood. When the fire is being released as you're burning something, right? What else is coming out of the fire? What happens? Smoke. So there you have air being released as well, as the matter is changing because of the fire. And then, have you ever seen green wood burn, and there's kind of like a bit of moisture in it, and that kind of sizzles and pops and so on? There you can see the actual water. And then what's left when you're done burning this piece of wood? Yeah, ashes. It just looks like So it's that kind of thing, where he's just speculating on these things, and people eat it up. They love it. They think this is great. There also is, by the way, a 5th element, a quintessence, that is what the heavens are made out of. Those orbs of light are made up of a special kind of substance, a non-earthly substance called quintessence, the 5th substance. It's kind of cool. There's the word quintessential. Have you heard quintessential? Do you know what it means? I don't either, but it's got to have something to do with the quintessence. I actually do. I'm just kidding. Plato is the other guy, the one who is also a Greek philosopher who's living around the time of Aristotle, who has a different kind of idea. Plato's ideas were not adopted by early Christians. Everybody just got really focused on Aristotle. And here's why. Plato is kind of more mystical than Aristotle is. Aristotle is very straightforward. He says there's 4 elements and a 5th element, and this happens and that happens and so on. Plato is, as you can see from, this is Raphael's School of Athens, by the way. This is the center of it. And you've got Plato and Aristotle sort of standing next to each other. And Aristotle's pointing sort of like down at the earth, like, you know, this is the reality of everything. And our friend Plato is sort of pointing up to the heavens and saying, basically, you know, we don't actually know. Things are much more mystical than you think. Well, Plato's ideas become popular during the Renaissance. And he gets dug up, so to speak, during the Renaissance. His ideas come back and people start to study them and they like them. At least some people really like them. Because it seems like he is doing kind of a, to use the word, a sciencey sort of, you know, mystical science sort of thing. Plato thinks that reality, that what we can see, what we can feel, what we can touch, is only part of what things really are. And so he talks about this idea of the cave, and how we, as human beings, are like somebody who is chained at the mouth of a cave. The cave isn't too deep, so we can see that the cave wall, the cave kind of comes right here and here. We're chained, we can't turn around. We can't see what's behind us. All we can see is the cave wall. And then there's a fire, or a source of light behind us. And so imagine that we think reality is what we can see on that cave wall. Does that make sense? But what are we actually looking at? Like if a giraffe walks by between us and the fire, what are we seeing on the cave wall? A shadow of a giraffe. And we'd be like, I know what a giraffe is. You know, it's got a long neck and it's black and two-dimensional or whatever. And we think that's what it is. What we're actually, though, what we're missing is all that stuff really going on behind us. So if you could break your chains and turn around, you'd be really shocked to see that giraffe, right? It's so much more. And so it's like in philosophy class when I was in college. There's, you know, they would say in philosophy, is this a chair? Or is this just our concept of a chair? And a lot of people, their minds were blown. Wow, that's really deep. And I'm very simple. I'm more like Aristotle. I'm like, well, if I hit you with that chair, if I picked it up and hit you on the head with the chair, you know, would you be going to the concept of a hospital or a real hospital? I never said that out loud, so I could get a B+ in class. But that's what I was thinking. The world is hidden. The true world is hidden. It needs to be revealed somehow. And how does it get revealed? Well, through what you and I might call mystical things, almost magical things. Or for them, maybe it has to do with math. Maybe combinations of numbers and fooling around with math and geometry and so on could reveal the true nature of this chair. The true nature of this chair is a giraffe. If we knew the right combination of numbers, it would turn into literally a giraffe. Isn't that cool? Should I try it? 18, 32, 6, 9, 5. Nothing. I need a new combination of numbers. Let me try a different one. We could do this all our lives, right? And it would never turn into anything. Because we just don't know how to make that happen. But the guys in the Renaissance wanted to make that happen. So they were starting to kind of play around with things to figure out the true nature of stuff. Our friend Pico de Mirandola, the guy who wrote the Oration on the Dignity of Man, he's really into Platonism and Neoplatonic thought. He's looking for a kind of universal spirit, or he's looking for the true essence of objects. Maybe we could find something like a philosopher's stone that would actually be able to, if we had this thing that we created, maybe we melted a bunch of metals together and said the right sort of incantations at the right time when the sun was in a certain place and the stars were in a certain place. Maybe we have a philosopher's stone, and I touch the chair with the philosopher's stone. Boom, it's a giraffe. Maybe. Maybe we could do this with numerology, fooling around with numbers. Maybe we could do this with geometry. Maybe we could do this with alchemy, like I suggested, melting metals together. Maybe we could do it with hidden texts. Think about how many texts they're discovering. Even Ptolemy's Geographica seems like a wonderful magical text when you find it. Oh my gosh, you can sail west and reach Asia. Or Africa's really big. We don't really know what's down there. Maybe we can get around Africa. There's so many things that are undiscovered that are being discovered in the Renaissance. I call this stuff helpful bunk. It's nonsense for the most part, right? But I think it is actually quite helpful. Because those things that they are doing are on the way to scientific sorts of areas of study. You guys ever have you ever fooled around with a Ouija board before? You know Ouija boards? They're fun. It's sometimes that's how I determine your grades. What grade for the SAQ for LE? Oh, it's a 3. All right. I figure the spirits know better than I do. The helpful bunk includes things like astrology. I recorded that, didn't I? Astrology, numerology, and alchemy. You guys ever read your horoscope in some way, shape, or fashion?
What's your zodiac sign?
I'm a Leo. What's yours?
I'm a Capricorn.
Have you ever noticed that the horoscopes fit everyone? You know? All right. Astrology is, you kind of know what this is, but astrology is the study of the influence of stars or heavenly bodies on human behavior. You think about, for example, with our horoscope, you think about when we're born. And when we're born, okay, thank you very much. When we're born, nice. When we're born, the planets and the stars were in a very certain place, and supposedly where those stars and planets and so on, where they were born, that had some sort of effect on what our lives will be like. You can also determine not just, your own personality or your own fates or whatever. You can also think about how the stars, how the planets are aligned if you want to do something. You want to create, for example, a favorable moment for yourself. You want to be married, maybe, at an astrologically good moment. So you would consult an astrologer who would tell you that you'd be married on July 15th at 3:33 p.m. And that would, for whatever reason, make your marriage good. Or, like Wallenstein did, the guy in the 30 Years' War with the giant army, he consulted astrologers to figure out when he should engage in battles to win the battle. It's a very normal thing that people were doing back then. In fact, the scientist Kepler, who we'll talk about here in just a minute, Kepler was not just somebody who was looking at planetary motion and coming up with the 3 laws of planetary motion. He actually wrote a horoscope for Albrecht von Wallenstein. Numerology is being able to predict events from combination of numbers. It's just fooling around with numbers, like I said. So it's the same kind of thing. You want to figure out when a treaty should be signed, when you should go to war, when you should have a battle, when you should be married, and so on. Maybe some numerologist can figure out when to do that. Sir Isaac Newton, the last guy that we'll talk about today, spends a lot of time trying to come up with a Bible code. Looking at the Bible and crunching numbers from the Bible to come up when the world will end, when everything will end. And I've got to warn you guys of something. It's during your lifetime. Sir Isaac Newton predicted everything's going to end during your lifetime. But here's the good news for me. I'll be dead. So, predicting events of combination numbers. But think about that. If you're fooling around with numbers, you're actually doing math, right? So, astrology is really sort of the precursor to astronomy, because what do you need to know? You need to know where stuff is. And if you're fooling around with numbers, you're doing numerology. And alchemy, my favorite one, is, once again, trying to turn base metals into gold. You're trying to take lead, and through a philosopher's stone, or through incantations, or codes of numbers, or whatever, you're trying to turn it into the most precious metal of all. It's not just valuable. Gold can sustain your life. You should be eating flecks of gold, my friends. Very small gold flakes can sustain you. Perhaps you'll live forever if you do that. So people are trying to do that. As they melt things together, as they find out the melting points of various kinds of metals, and as they're putting things together, and then making amalgams and so on, you know what they're doing? They're doing chemistry, basically. So, helpful bunk. During the Renaissance, the classical view of things, looking what the Greeks and Romans had done, looking what they said, and then starting to use math and observation and experimentation, makes people realize that the Greeks and Romans didn't know everything. That some of the stuff that they said was wrong, or not provable, or, well, once again, you drop the balls, one of them's heavier than the other, and they hit the ground at the same time. Well, what's going on there, Aristotle? Or they start to explore other parts of the world, and these Greco-Roman experts knew nothing about the rest of the world. Well, how much do they really know? So as they start to figure out errors, they start to doubt the Greeks and the Romans, and start to believe in their own ability to come up with scientific laws, using Mo. At this point in time, too, science is kind of a lot like art. You know how art had patrons, people who were paying for it? People are paying for science at this point in time, too. The Medici family is paying people to make scientific discoveries, or to fool around with numbers and alchemy and all these other sorts of things. It kind of makes sense to me. If you were somebody from the Medici family, wouldn't you want to know when propitious moments for various kinds of things are? Wouldn't you want to know when you should assassinate your rivals? Wouldn't you like to be able to make gold and then, live forever and then buy as many soldiers as you possibly needed to conquer the rest of the world? Artists, too, at this point in time, were using geometry. They're using math. They're using perspective, and they're trying to figure out proportions. How big somebody's face should be, where their eyes should be, how things should look. When the era of exploration comes along, you've got to figure all those explorers are using the stars to try to figure out how far they're going and where they're going, and so on. It's all very helpful, like I said. Well, math, observation, experimentation, these are the kinds of things that they start to use during the scientific revolution. And they're going to use Mo in order to come up with laws about how things work. They're starting to use technologies that are being developed around this period of time. Ways of measuring things more precisely. Things where they could observe things more precisely. So the telescope is used to look at things far away, the heavens, for example. A thermometer is used. Do you guys take your temperature every day? Do you ever take your temperatures?
Yeah.
Charlie, do you? Okay, good. Like Kobe sort of thing, where you're like, oh god.
We have both.
Yeah.
We have the scanner.
Yeah,
And
me
you
too.
put in your mouth.
Yeah. I do it all the time.
Sometimes it's fun.
Yeah, it is fun. It's always 97.2. Thermometer, measuring temperature, a clock, measuring time, a barometer, measuring air pressure. Pendulum is kind of an early clock in a way. You count things using a pendulum. The microscope, the little tiny things, an air pump itself, pumping things into and out of a glass container. I think there's a picture in your book, if I'm not mistaken, of these people standing around a big glass container with a bird in it. They've pumped all the oxygen out, and the bird is dying. It's fallen at the bottom. And hopefully they'll let the oxygen back in, revive that poor bird. Also, the printing press. What's the printing press do? It spreads ideas, yeah. Here's the thing to think about, though. If you were an alchemist and you did it, you came up with a way of turning base metals into gold, would you print that and share it? Oh, hell no. See, magicians, people who are doing these secret things, never want to share their ideas. The scientists want to share their ideas. And so that's kind of how you know the difference between a magician and a scientist. So let's buzz through a whole bunch of different people and their discoveries. There's this guy by the name of Nicholas Copernicus. He's Polish, and he is a churchman. And Copernicus is tasked with finding out when Easter is for hundreds of years. You and I, if we care about when Easter is, we know when Easter is by looking at a calendar, right? But if we didn't have a calendar, how would we figure out when Easter is? We'd have to know about the moon. Because Easter, you know how it changes every year? It's based on a lunar calendar. And so he was supposed to do that. So he's looking at the heavens quite a bit for the church's sake. And he discovered that AP, that's Aristotle and Ptolemy, that they had created a system that didn't really jive with what he was seeing. That Aristotle and Ptolemy, their system was just chaos. In order to explain where things ended up, he had to create things called epicycles, really starting to bust up the whole idea of the Earth at the center of everything and these crystalline spheres. Because the crystalline spheres, or these orbs in the crystalline spheres, would travel across the sky, but sometimes they would jump back in these weird ways. And so people started to say, well, maybe the crystalline spheres just sort of, the orb is actually rotating within the crystalline sphere somehow, and that whole thing is moving. It just got really chaotic. And he said, God is perfect. He wouldn't create a chaotic system. There's got to be a better way of explaining the movement of the stars and the movement of the planets. And that's why he comes up with this kind of ludicrous idea that the Earth is not at the center of everything. He says, look, if you put the sun at the center of everything, and the Earth is actually rotating around it, that accounts for how things seem to be, things are the planetary movements and the movements of stars make much more sense if you do it this way. And he writes all this stuff down, but he's afraid to have it published. He's afraid people are going to laugh at him, or that he's going to get in trouble. Because the church says Aristotle and Ptolemy is right. And so he sits on his ideas for a really long period of time. It kind of clears things up. It helps him figure out when Easter is. But he is hard to convince to publish things. He finally is convinced to publish his work basically on his deathbed. So he can't really get in trouble. And then just to make doubly sure, if he gets out of his deathbed and gets better, he decided to do a foreword or an introduction, and he addressed his introduction to the Pope. He writes this work for the Pope and says, essentially, Your Eminence, if I'm wrong, I take it all back. But this is for your perusal. It's called On the Revolutions of Heavenly Spheres. If this idea is correct, if the sun is actually at the center of things, which is weird. Why would God put the sun at the center of everything when man is made in God's creation, or man is made in God's image? But if you do that, if this sun-centered or heliocentric theory is correct, then it's the Earth that's rotating. Earth is moving, not the stars, not the planets. Maybe there are no crystalline spheres. Maybe there is no quintessence. Maybe there's no ether. Maybe those orbs of light are made of the same kind of stuff that you have on planet Earth. If there aren't crystalline spheres, if we're rotating, and the stars are fixed, then the universe is absolutely enormous. Where does God live? Where's heaven? Is the Earth just another planet? Why in the world would the Earth just be another planet? God made man in his image. God put Earth at the center of everything. It's very disruptive for people who think about these things. Catholics and Protestants were outraged. I think Catholics were outraged because the Pope and the Jesuits and the whole church hierarchy believed Aristotle. They didn't like somebody coming up with new ideas and saying that they were wrong. They hated that. The Protestants have been doing that for a little while. And the Protestants hated this idea too. Luther wrote something against Copernicus. He thought he was crazy. And he does so because of sola scriptura. In the Bible, you can read that this guy named Joshua made the earth stand. Wait, he made the earth stand still? He made the sun stand still. Yep, he made the sun stand still. So the sun was moving. It's clear that the sun was moving, according to Luther. Well, Copernicus lives, he dies, his ideas kind of spread a little bit. Some people start to gravitate towards it. The vast majority of people still believe Aristotle and Ptolemy, and they're not willing to go along with it. There is this really interesting person, probably one of the most interesting people in European history, a Danishman by the name of Tycho Brahe. Tycho Brahe was given an island by the Danish king to go and live and to use this island as kind of his own personal domain, and then also to record the movement of planets and stars. He has an observatory there. And he spends years on this island just making, coming up with data, recording where things are, recording where they're moving to. And he's doing this through the O of observation. By the way, I missed talking about Nicholas Copernicus. He's using a little bit of math, and he's using a little bit of observation. So just collecting a whole bunch of data on the movement of celestial bodies. He also observed a comet that was traveling, across the night sky. And he thought about that and said, well, if there are crystalline spheres, wouldn't the comet be busting through these crystalline spheres? And wouldn't that be problematic? There's a whole bunch of other wonderful stories about Tycho Brahe. He apparently had a pet moose. Yeah, and somebody, he would have these parties, and somebody got the moose really drunk, and the moose fell down some stairs and broke its leg, and they had to destroy the moose. It's kind of a sad story. Sorry about that. It's a moose drunk. How did they get it drunk? They fed it alcohol. There's also a wonderful story, I don't know if you can tell by looking at him, but he had a prosthetic nose. He had a fake nose because he got into a fight with another guy over who the better mathematician was. And they had a duel. And in this duel, he lost his nose. And then created a nose made out of metal that he could just pop right in there. That's kind of cool. And then the last thing you don't need to know about Tycho Brahe, I'm going to tell you anyway, is he died because he didn't go pee. He was hanging out with the Holy Roman Emperor in Prague at a banquet for the emperor. He didn't want to leave the emperor, didn't want to get up from the table because it's rude, and so he had a kind of like a weak bladder, and things went bad for him, and he dies from that. So the lesson to be learned from that: 3 lessons. 1, don't argue with people over who the best mathematician is. 2, don't get an elk drunk, or don't get a moose drunk. And then 3, if you need to go to the bathroom, just go to the bathroom.
Can I go to the bathroom?
Sure. We don't want your bladder to explode, Harry. Johannes Kepler works with Tycho Brahe. Both of them are hired to work for the Habsburg family in Prague. And Brahe really wasn't that great of a mathematician, quite frankly. So he deserved to lose that duel. Johannes Kepler takes Tycho Brahe's information, and he actually is really quite good at math, And he figures out, using math, that planets travel not in circles, not in perfect circles around the Earth, but in ellipses around the sun. Planetary orbits are elliptical. In fact, he comes up with the 3 laws of planetary motion. Elliptical orbits. Another one has to do with how planets speed up as they get closer to the sun and slow down as they move farther away from the sun. And the speed that they go at is it's related to how close they are to the sun. So I think Mercury has like an 88-day year. Just flip around the sun all the time. And Neptune or Uranus is like a 26-year year. Another thing that this guy was working on, that Kepler was working on, was trying to figure out the true essence, from Plato's cave, or what this chair really is. He was trying to find this thing using music and his observations of the planets, or really Tycho Brahe's observations of the planets. Imagine if you record where a planet is in, let's say there's a church steeple, right? Sorry, you guys at home can't see this, but let's say there's a church steeple, and at 9 p.m. every evening you go and you see where Venus is. And Venus is, on the first night it's here, and then Venus is here, and then Venus is here, and then, that's weird, Venus is here, and then Venus is here. Imagine you have all of these different positions at 9 p.m. of Venus that you're observing. You could put maybe if you could turn those into musical notes, I don't know how to do that, but if you could turn that into musical notes and then play that song, it might be the God song that would reveal the true nature of all things. You'd suddenly stop seeing shadows of giraffes and see the real giraffes. Just play that. He never finds that. Oh, shucks. Would have changed everything. Let's move from the Holy Roman Empire to northern Italy, and we have the career of Galileo. Galileo is working for patrons, as I said. You might have noticed too, the church was the patron of Copernicus. Holy Roman Emperor or the Danish king were the patrons of Tycho Brahe and Kepler. Galileo Galilei's patrons are the Medici family for a while, and he's trying to figure out rolling balls. He's trying to figure out inertia. He's dropping things from various bodies, heavy things, light things. He comes up with a law of accelerating bodies, for example. He's using a telescope to observe. He's observing the moon and seeing that the moon is not made out of quintessence, but it looks very much like what we find in sort of deserty regions here on Earth. He's looking at Jupiter. He finds 4 moons of Jupiter by looking very closely. He's looking at sunspots, which is a really bad idea because it destroys his vision. And he's basically blind at the end of his life. Don't look at the sun. There's another practical thing to learn from today. And so he's basically saying, look, we don't have a perfect universe. We don't have quintessence. We don't have crystalline spheres. You can see that things out there are much like they are here. Writes a book called Starry Messenger in 1610, once again looking at how comets come racing through the sky from time to time, or how you might have like a supernova happen. Stars get infinitely brighter, much brighter than they had been before, and then they seem to disappear. How is the universe unchanging and perfect if that kind of stuff is happening? But really where he gets in trouble is with the Catholic Church and the Roman Inquisition. In Catholic countries, the Catholic Church is in charge of all of the scientific knowledge. It's in charge of all knowledge, really. And Galileo decided to write a book. He was warned about supporting Copernicus, but he writes a book that sets up a debate between somebody who believes in Copernicus's ideas and somebody who believes in Aristotle's ideas. This book is called A Dialogue on the Two Chief Systems of the World. Well, once again, he was warned not to spread Copernicus's idea. He says he's not spreading the idea. He's just setting up a debate between these two dudes. But in reality, the guy who's supporting Aristotle, his name is like Simplicio. He's simplistic. He's dumb. And so everybody gets that this is sort of a pro-Copernicus, anti-Aristotle, or really anti-church at this period of time, and pro-science kind of track. Well, the Inquisition, the Roman Inquisition, calls him and says, you're spreading heretical anti-church ideas. And he gets really scared, and they say, we need you to recant, we need you to take back everything, and then we won't torture you, and we won't burn you at the stake. And Galileo, as a blind old man, says, you betcha, I can do that, gets on his knees and begs for forgiveness. But his ideas were already out there, and people already kind of knew. That this was the right idea. By the way, why do you think that Tycho Brahe and Kepler were not persecuted? Think about where they live in the Holy Roman Empire. If anyone's going to persecute them, who's it going to be? Who would have control over them? Why wasn't Martin Luther burned? Who protected Luther?
Like the local nobles
Yeah.
who are in charge of running the territories.
Exactly. They don't care.
The Catholic Church really want to.
You got it. Yeah. Finally, there's an Englishman who looks at everybody else's work and is a really odd fellow, brilliant and odd. Sir Isaac Newton. He looks at Copernicus's idea, loves it. At Brahe's data, loves it. At Kepler's ideas of planetary motion, loves it. Galileo's law of inertia, loves it. And he puts it all together using math. Apparently he's really good at math. He creates calculus for you using observation and experimentation to produce the Principia Mathematica, in which he explains the three laws of motion. Like I said, he's doing a number of other things too. He's figuring out how vision works. He's figuring out, he's trying to figure out the Bible code to tell you when the world ends. I think it's in 2067. And if I'm still alive in 2067, my goodness. I'll be 250 years old at that point in time. You can do the math, I just need a lot of gold flame. He creates the notion that man, using reason, and I call it math, can explain the universe as a very complicated machine. Kind of like a clock. You know how complicated clocks are, old-style clocks, all the gears and gizmos and busy things all going around. That's the way the universe is. And God, he really believes in God. God is sort of like the eternal clockmaker. God set up everything in this extremely complicated way and wound it up and let it go. And if you're a smart person, you kind of look into God's creation and figure this out. A lot of people were afraid to do that before. It seems heretical to try to figure things out that God had set up. But other people, like Isaac Newton, think, no, this is a great idea, actually. It's supporting the existence of God and showing how God is logical and rational, too. Kind of a fun story about Isaac Newton, too. As part of figuring out how light worked and how vision worked, he played around with those prisms. Do you guys ever have a prism? You shine light through it, and it gets into several different colors. That's really kind of cool. But he's a real scientist. He's a real, he's going to do it all himself. And so he wanted to see what was behind his eyeball. So he took a knitting needle and stuck it between his eyeball and eye socket to kind of push this eyeball out of the way to see if he can see what was back there. He lost his vision for a few days. That's like the sixth thing I told you. That's really good advice. Don't stick things in your eyes or between your eyeball and your eye socket. So, MO, math, observation, experimentation, lead to a mechanistic view of the universe. The universe is a machine, like a clock, super complicated. And this scientific method, this MO, is going to be supported by some other people who aren't necessarily scientists, they're more like philosophers.